So, all right, I think you can see my screen now, right? So thanks, Simon, for the introduction, and thanks for having me at this Virtual JUG 24 Hours conference. And what we're going to do today is we're going to have a look at a lot of different libraries, which hopefully allow us to write nice functional code in Java 8 and the next versions. So first of all, like Simon said, I'd like to thank a bunch of people which actually responded to my little survey on Twitter, where I asked the people to send me some links of the different libraries which they use and which they like. And I got like 26 different replies, so I can't really cover them all in this talk. So I'm going to show you some selection of it. So what do we have in Java 8 now? It added some functional, stylish additions to the language. And first of all, we have this sometimes, which is the abstract method interfaces, which just have a single abstract method. And this allows us to actually pass in some lambdas. And what I think is really, really nice, that it's also backwards compatible. So the libraries don't really have to compile for Java 8. If they just have the right interfaces, we can still use them with the lambdas. And some of the standard functional interfaces, which were also introduced in the core Java library, are some function, predicate, supplier, and consumer interfaces, which we just have as basic building blocks. And then we also have default methods, which now allow us to actually call the sort method directly on the list and sort them instead of going the way over the collections class, which is also very nice. And also, functional languages usually allow to compose some functions. This is how we do it in Java now. Suppose we have a function which can add up two numbers, x plus y, and we also want to multiply it by 5. And then we call on the add function, we can call a method and then, and pass on the lambda, which then multiplies by 5, and we get a new function. And if we call that function and pass in two values, 2 and 5, we have 2 plus 5 is 7 multiplied by 5, give us the correct result, which is 35. Very nice. Then we also have a nice addition in Java 8, streams. So streams basically allow us to abstract over different input sources and call some standard methods on it. So we have some intermediate methods like the filter method in this example. And those are all executed lazily. And then we have some terminal methods which actually give us back one result and only execute the lazy methods once they are called. So much for the recap. Now let's do a nice example. What we usually have in our office when 2 or more people have a birthday on the same day, and then they offer some breakfast for the co-workers. So what I want to code is actually find all the birthdays of all co-workers which are in this month, group them by the same day, and then send emails to each group of persons and ask them to organize a breakfast together. So let's have a look how this actually looks in code and go to our IDE. And let's code this, right? So we have our employee register here where we get back all the employees, and we have already the current months. So what we do now is, here's our task up there, what we actually want to achieve. And then we call persons.stream to get the stream from it. Then we call the filter method to actually find all the birthdays in this month. So we have from the employee, get the birthday and get the months and compare it to the current months. This is all very nice and works perfectly. And then we want to group it together. There's no group method. All right. I think it's the collect method, and then we can say grouping by. Yeah, that's right. And we actually don't want to group by the birthday itself because it already has the year. Then we only get the persons which are already born the same year. So we have to do something else here and say month day from get birthday. And then we have a group of the people all with the birthday on the same day. What we actually have here is that collect is a terminal function. So we have to stop here. We get back a map. We just assign this map. This is actually a multi-map. So we have multiple persons with the birthday on the same day. And what we now want to do is we want to only send the mail out if there's more than one person on the same day. Otherwise, they have to spend so much money to give a big breakfast. And yeah, we have to filter those again. So we call map.entryset.stream, and then we filter those. We now have map entries. So I have an entry, and then I call eGetValue.size is bigger than 1. And now I actually want to sort them, so we can have a list by the birthdays. And what we can do here now is pass in a function which sorts over the values. Yeah, I wish it was like that, but we have to pass in a comparator. So we have to call comparator.comparing, and then we can actually pass a method reference over the key, get key, and then we have them sorted by the birthday. Oh, I forgot a brace here. And then we can actually call for each, and for each of the entries, we can now say send mail with eGetKey and eGetValue. I already implemented that method. So now we are done sending out the emails to all the different persons on the same birthday. All right, that worked. But I think there were some problems in this code. Actually, Lambda sounds a bit like Lambda. So we actually, Lambda is a nice dance, but it's not like this, right? This is a limbo. And it kind of feels like we have to duck underneath some firebar. So the problems were, how's that method called again? It's not grouping by, it's probably collect. Then we have to pass in a comparator instead of a function. And there's some additional problems like some basic functions, which you know from functional languages, like the zip method are missing. And how do I actually get a stream of lines from the file? I have to call the files class for that and can't do it on the stream directly. And we are missing immutable data structures as well. We're coming back to these points later and do a recap on these. So before we start, there are actually other JVM languages which are more functional, like Freg, for example, is Haskell for Java. That's a functional language. And Java is always very conservative in adding new API. But I think the Lambdas are already a great addition. We have so many possibilities now and can build so many things now. And additional API might be added later. So if you, for example, have some nice libraries and you use them in some public repos, actually the core Java team goes there and checks which methods might be useful to add to core Java as well. So we might get them later. So one thing I have to ask you before you actually use one of the libraries I'll show in my presentation, before you use them in production, like usually, please test drive them somewhere and have a look if the performance actually is good enough for your product. So let's have a look and for some libraries which actually add some functionality to streams. The first one is called StreamEx, so it extends streams. It extends them and actually wraps them. So to create a new StreamEx instance, I can call the StreamEx-off method either with an existing stream or I create a new one with some values. It also allows parallel execution, but like the original stream class. There's some shortcut for the collector methods, so I don't have to call the stream collect.grouping. I can call stream grouping directly, and also offers some more functionality. For example, it also implements iterable. So if we actually want to use some older API, which we already have in our code, like for example here, I have this print email method, which I already had, and it expects an iterable. If I have this StreamEx method, I can call it directly with the stream, which doesn't work in Java because it only offers the iterator and is not an iterable. So let's go on. Factory methods, like I told you, if you want to have a stream of the lines of a file, you have to go to files.lines, and there you have it directly on the StreamEx as well. And then you can also create a stream from keys or values of a map, and a lot of more different methods, which is just an extract here. For example, you can also have a direct stream from splitting a string here and passing in a dash. or you can have a stream of a tree-like structure. It's an arbitrary tree-like structure, which you can decompose here with a function. And for example, I can create a stream of my path on the file system here. Then some nice methods which we have directly on the StreamEx, if we already created one, like with this one. And then we call, for example, a prepend method, which adds some items to the beginning of the stream, or we call the append method to add them to the end of the stream. Then we have some folding methods, which are missing from the standard API. And we have a group runs method. You have to be a bit careful with this one. It's not really an intermediate operation, as we see later. And what it does is it actually groups adjacent elements together. So here we say group by the criteria that the adjacent elements are equal. And for this example, we get the group from A and A. We get a new list grouped in a list of lists, for example, back. And we also have a nice distinct method addition with a parameter. So we have at least also as an addition. Let's go back to our original example, our Java 8 code, and let's see how we can implement it with the StreamEx library. So for StreamEx, we can we first have to sort by the birthday, so the day of the birthday here. And then we can call the group runs method, because then we have all the days adjacent, so next to each other. And then we can call the group runs method, which actually gives us back a list of the list, or a stream of a list. And then we can call filter on these again to sort out on the single birthdays, and then we can send the mail. So that's very nice because it's all fluently, but you really have to watch out because group runs actually isn't a really lazy operation. It's a kind of terminal operation, but it allows a fluent style here because we can just go on. Let's have a look at another library, which is called JUnit. That's actually not the icon of the library, but it's just here for pronunciation reasons, so you have an idea how to actually pronounce it. And it's quite similar to the StreamEx library. It also implements stream and iterable. There's a big difference, and it's only sequential, so we don't have any parallel processing here. So calling parallel has no effect. Otherwise, it has some similar functionality, but because it's a companion library of the Juke library for type-safe SQL queries, we have like collector's magic, which we'll see later. And we also have some functions from 1 to 16 parameters and some tuples with 1 to 16 values. So I can do something like that here. I have a tuple with 4 values, and this is tuple 4. And then I can actually call a function with 4 parameters and 1 result value and do it directly in the code. We have also some nice factory methods to create our sequence class. For example, we have a cycle method here, which repeats the stream we pass in or the values we pass in indefinitely. And we also have a scan left and scan right, which is a fold with intermediate results. We have a grouped, which doesn't produce in a map, but a tuple 2, which can also be seen as a map, and some other methods. And we also have a zip method as well, which can zip a lot of collections just in one go with a factory method. It's also a big problem in Lambdas, especially with the standard functional interfaces we get, that they don't allow exceptions. So for example, if we want to process some code on the stream class, and here we want to read a file, so the lines of the file here, and then it throws an IO exception because it doesn't allow to actually have checked exceptions in the functional interface. We have to wrap it in the runtime exception here. So instead of passing a method reference, we have to do a Lambda body here, which is not so nice. So what Joule actually can do, it has an unchecked method, unchecked class, sorry, where you can call different methods, which are according to the functional interfaces we have. And it does all the wrapping magic for you. So this wraps everything in a runtime exception, and we can just pass on the method reference, and then we have it in one line. So it's available for the standard functional interfaces as well. Some nice additions to the sequence API as well. We can format the contents of the stream for debugging purposes. So if we want to see what's in our sequence. The intersperse method inserts elements between all the existing elements. And then we have some SQL stuff like left outer join, right outer join, and inner join, which all join by join criteria, which you have to pass in. And then if you join the two lists, ABC one list and 1, 2 the other list, and you do the left join, you have all the values from the left side and only those from the right side which match. Here we don't have a match, so we have a tuple with a null value. So if you go back to our Java 8 example and see what we had here, and let's see how we can actually solve it with JUnit. And we see that we have the sequence class here. The filter method is all the same. And then we have the grouped method, which actually does the same like the grouping method before, but it returns a tuple. Then we can directly call the filter method here, and we can sort it. And then we have the for each method, which actually sends out an email. So it's much more fluent style when we see it with the streams. And then JUnit also has something nice, which is called window functions, which we know from SQL. So what is a window function? A window function does calculations across related elements without grouping them and producing a single result per input element. So we have a nice example here. If you watched the session by Lucas with the SQL tips and tricks earlier, it might be you might already know the solutions for this, but let's say how we can solve it in Java instead of SQL. So what we have here is my bank account with all the withdrawals, like minus 20 euros on the 11th and the deposits 100 euros on the 20s. And what I want to see is the account balance for each date. So if you want to do it in with JUnit, we can actually create tuples. So we just copy and paste from our bank account, right, and create a tuple with the date and then the actual amounts. Then we call a window function on it. So what does this function actually do? It says comparing by value 1. So in our tuple, it's our date. So it's ordering actually by date and taking into account all the previous values of each date, because we say long min value, until the element itself, so until 0. So what we do here now is we order all the lists. So we have the 11th, the 20s, and the 27th. And then the window function does the following. So for the 11th, it only selects the 11th because it doesn't have any previous values. For the 20s, it selects the 11th and the 20s. And for the 27th, the 20s and the 11th and the 27th. And we also have the values for it. So this is our windows. So that's why it's called window function. And now we can do some calculations over the window. So we have the original window value, which is our tuple 2 from above. And we can call concat on it and create a tuple 3 from it. So we add another value to it. And the value we will add is the sum of our current window over all the values. So the value 2 from our tuple. And what we actually achieve is for the 11th, we have only one value, minus 20. For the 20s, we have minus 20 plus 100 is 80. And for the 27th, we have all the values, which is sum of 75. And then this is our result, actually. So we have 3 input values, and we have 3 output values with all the totals for each date. I think that's also a very nice addition. And also as a printout method to quickly print out the results. Let's have a look at a very small library, which is called StreamUtils. So before we were actually extending the stream. The StreamUtils class is transforming our streams. So we don't have any methods to call from it. We only have some factory methods, which actually directly transform the stream. We also have a cycling method to infinitely repeat the stream. We have some grouping methods where you can pass in a grouping factor and create groups of your input values. We have repeating, for example, with this as a repetition factor of 2. And we have rolling with a rolling factor. And we have also like interrupting and gating. Interrupting means stop the stream processing at a certain predicate, in this case C. So we stop after A and B. And gate means start the stream processing at a certain predicate. And I want to give you a little example. You know, there's always some elections going on around the world, and we want to make sure that they actually get the counts of the election right. And what we have is a voting card with 2 string values, because usually you have to make some X's with a pencil on the voting card. And so valid vote means that you only made 1 X for one of the candidates and left the other one blank. And an invalid vote means, like, for example, you made 1 X and for the other you scribbled like "I hate you." This is usually considered as an invalid vote. Then we have the vote interface, which counts actually the numbers of the votes. With the StreamUtils, we have a validate factory method. It's not really a factory method, transformation method. And there we pass in a stream. In this case, we have our voting cards, which we pass in as a stream. And then it has 3 different functions. The first one is a validating function. So it gives us back if the vote is valid or if it's not valid. And then we have 2 functions actually transforming the input value. So one for the valid vote. So from a voting card, we get back a valid vote. And the other from the voting card, we get back an invalid vote. So they're called depending on what the first one evaluates. And so we get back all the vote results. And because it's now our vote interface, then we can just sum them up with the getInvalid method. And then we have the sums of all invalid votes. So should be fairly easy, right? Let's have a quick example for what we can actually do for our logging code. So with Log4j starting from version 2, we also have can use lambdas for our Java logging statements. So before Java 8, you have to call something like this. For the trace method, we don't want to execute this expansive operation as tracing is not enabled. So you had to guard this actually with an if statement here. And for starting with Java 8 and Log4j 2.x, you can actually call the trace method directly. And for the last argument, you just pass in a lambda. So it doesn't get evaluated if tracing is not turned on. You can also pass in a message directly, which gets lazy evaluated as well. So on to testing. Do we have some nice testing libraries with lambdas? Let's first have a look at JUnit 5. So JUnit 5 is a successor to JUnit 4. It's still in beta, so it's actually a milestone 2 now, but it's expected to be final release at the end of this year. Let's have a quick overview of what we actually have in JUnit 5, so you get an overview for that. So you can have a display name for your test classes, which are shown in your UI instead of the test class method, and they don't have to be public anymore. It's also nice. Then we can add tags, where we can tag our test methods. For example, is this fast enough for hourly runs in our continuous integration system, for example. We can select the test later. And then we have parameter injection as well. So one of the standard parameters we can inject into a test method is a test info class, which is provided by JUnit, where we can, for example, read out the display name. Then JUnit 5 was funded as JUnit Lambda project. And this means we also can use lambdas. First of all, the optional search and message parameter is now the last one, not the first one anymore. And then you can also have a lazy evaluation by just passing in a lambda here. What we can also do with lambdas is now usually our test method or test case fails when the first assert fails. Sometimes we want to assert more than one value, and we can do it now by passing in different lambdas, which actually are the assertion bodies in this case. So we have the assert all method with 2 assertion bodies here. And if they both fail in this case, we have multiple results back, so we get them both back. Exception handling also changed with JUnit 5. We don't have this annotation-based style or the try-catch style anymore. We can have a method expect throws. We pass in our exception, and then we have the function we will want to call as a lambda body. I actually tried vjug24.com because I didn't think it was registered, but it actually was. So my test did fail because it didn't throw an exception, so I had to put in vjug26.com. I don't think this will ever happen, right? So another example is, let's see, we have the statement like all Fibonacci numbers over 2 are odd. So we want to write our test cases for it. And we want to have them for each of the Fibonacci numbers. We want to have a different test case showing up in our IDE. And so we write the first method like test the Fibonacci number for 1 if this is odd. Okay, that looks good. And then we do it for number 2 and 3 and 4 and 5. So this is very, very boring, right? And what we can do with JUnit 5 is actually we create a range of our input values from 1 to 20. Then we map this to a calculation of the Fibonacci number. And then we can further map this to a dynamic test case where we can pass in our name for the test case. And then we pass in the method body as a Lambda as well. And then we just have to wrap it up in a test factory method where we return dynamic tests, a stream of dynamic tests, and we annotate it with the test factory method. And then it really shows up nicely in our IDE. So we have all this different Fibonacci number test methods here. And you see one of them fails. There's another one which fails. So our assumption was really right. So let's do a recap now for the functional programming in Java 8. Let's see if it really was some kind of evolution here. And let's recap some of the features we already have for functional programming. So for functional programming languages treat functions and values as the same. So we can also pass functions around, not only values. And we have the pure functions, which say for the same input, you always have to have the same output, and you're not allowed to have any side effects. So what does it mean? Let's, for example, have a look at our input list of values here, A, B, and C, and we call a method called calculate results. And this calculate results method, we don't know how it looks like, but we expect that our values still remain the same afterwards, right? Just should calculate some real results and not change our input values. Actually, the method looks like this. So it removes all the values if the length of the string is shorter than 2. So actually, we end up with an empty list afterwards. So you should always favor immutable data structures. Actually, we have a nice library for this, which is called Javaslang, which is functional Java programming additions, and they have immutable data structures, for example, immutable and persistent collections like list and set and map and variations. They also have the same name like in the core Java. And we also have like pure functions, and we also have like the tuples we know from Joule. And we have all the stream-like methods on all the collections directly. So we don't have a stream concept, but we have it on the collections directly. But be aware that it's a different concept, right? You're not interacting on stream, but on the collections directly, but they are immutable, so you don't have to worry about it. There's another concept we also know from functional programming language, which is called currying. Currying means fixing one of the values of a function. So we have our add method again, where we add a plus b. And we want to fix the value a to the value 2. So we can call sum.curried and apply 2. And then we only get back a function 1 because it only needs one input parameter now. And if we actually apply the value 4, then it adds up 2 and we get back the value 6. Nice. Then the concept of partial functions is the one that a function is only defined for certain input values. So it's only partial. So, for example, the divide method is only defined for divisors which are not 0. And so this divide method throws an arithmetic exception if I actually have a divisor of 0. And in Javaslang, I can call a method called lift. And lift will make our partial function into a total function by just doing some exception handling. And now we get back an option. So it's like the optional in the core Java. And if we now pass on 0, we get back a none and not an exception. If we go back to our original Java 8 example, our original code here, let's see how we can solve it with the Javaslang collections. So this time we have a direct collection. It's just list, right? We don't call any stream method here. We just go over the collection and filter it. And because it's immutable, we get back a new collection. So then we call a group by method on it directly. So we group by the birthdays, then we call the filter method, and then we can pass a method reference because it's a tuple here. So we can have a method reference for both parameters. So compared to our Java 8 example, it looks much nicer because it has a Fluent API. Well, there's a little trick to have it in Java as well, right? We can, on our map, we can directly call .entrySet.stream as well. So we have it fluently, but well, it's different concepts. Let's do a little excursion and look at some SQL code. There's a library called Jink, which is kind of a proof of concept link for Java. Link is a language we have in .NET for writing SQL queries directly in our code. And so Jink does this for Java, and there we can do something like that, like database.customer stream, which means a select from the customer table, and have a where method, and then we can just pass in a Lambda. Fits very naturally and maps to this SQL code. So like I said, it's really proof of concept. I don't know how far it is. If you can already use it in production, I'm not sure. Let's go and have a look at a reactive library like RxJava. So RxJava is nice because it really takes into account older Java users as well. So it works from 6+, but it has functional interfaces which allows to use lambdas in our Java 8 code as well. So the base class is like something like a stream. It's called observable in this case. We can create it from a list, for example, but usually we create it from a database, from a message bus or something like that. So we have a constant stream of values. What it also has is like some excellent Java doc with flow diagrams of the operations. So if you did never understand this flat map method, what it actually does, here you have a picture for it. One basic concept of the RxJava is not only the observables, but it has subscribe methods. And on the stream, you can only call a terminal operation once on the Java stream. And on an observable, you can actually subscribe multiple times, which is kind of a terminal operation. Here you can see we have some output methods for the subscribe method. You can call subscribe multiple times because you get copies of the observable back. So the basic methods, like I said, are looking like the same for streams as well. But the real power comes when we look at some time handling code, like for back pressure, for example, for interval handling, for windows. So what it does actually mean is, let's have a look at the source code for this. Here I have an example source code. So we create a list from just some input strings, and then we zip this list with a timed creation of values. So once a second, we just create some arbitrary value. We don't care for the value, we just throw it away again. But now we have one of the values of this list once a second. What I can say now is I want to take, for example, in a window of 10 seconds, I want to get all the values which I get in 10 seconds. I want to get it back as a list. So I get them grouped. I can say, okay, only take the values for the first 5 seconds. And then let's have a look how this actually looks like if we execute it. So we have one value coming every second. For the first 5 seconds, we have then duplicately because we told them to take it. And then after each 10 seconds, we have a group of values put out, which were happening at the first 10 seconds. So I think this is very nice if you need some more like timed handling of stuff. Also have some nice error handling as well. So on error resume next. So if you have some error connecting to a web service, for example, you can directly call on error resume next and connect to the next web service, for example. Then let's have a short look at the microservices. Earlier, you already had a session about the Vert.x library, but I just want to give you a quick overview about it. So with Vert.x, you can create reactive applications on the JVM. Today, we mostly say it's like microservices. So you have different verticals, which are like a microservices and can also stand for each own. what I really like is that it has a lot of integration components for authentication. We can also integrate it with RxJava if we like to have it in a reactive style, where I have clustering with Hazel calls, for example. And this is how you can create a very simple web server. So you just say create web server, and for the request handler, so if a request comes in, we just respond with hello world and end the request. And then it builds up our web server and starts to listen on port 8080, and we can just use it as a web page. Very simple. But we can also use it for other microservices as well. Microservices don't have to be always web-based. We can also build some file reading application, for example, which does it asynchronously and non-blocking and just reads a file. So it reads a file from this location, and it will asynchronously call our Lambda here and tell us if the reading succeeded, and then we can print it out, or if some error happened, for example. All right, that was the end. That was very quickly a lot of libraries. Actually, I didn't show you all of the libraries because I had to throw some of them out again last minute, but you can actually find them in the slides. I will upload them later and share them on Twitter and on my webpage. And also I have some more libraries which I didn't cover in my slides, but which were mentioned in my Twitter survey. So if you want to have a look at these, for example, we also have this Akka Streams here, where we also had a talk today. So you might want to listen to that as well. And just have a look which library actually fits your needs the most. So there's some bigger ones, there's some which add collections, there's some which that just extend the streams or just do some stream transformations. There's a lot of different libraries around. All right, slides and code can be found here. And you can also contact me on my Twitter handle, so feedback is very welcome.
Awesome, thank you very much, Rabea. Look on this now. Nacho from the Barcelona Jug. I believe you have a question. So I don't think you put it in RC. So if you have,
yeah, can you hear us?
Yeah, we can hear you.
Yeah. So the question was only related with these libraries. Can you recommend all of them, or just because I found many of them very interesting, but let's say there are many problems or there are no problems at all. Which one is the best approach to use it? So more or less it's a kind of understanding what do you recommend?
I actually have no idea because I didn't use any of the libraries in production. So I just prepared it for this talk. So because I found the topic very interesting, and I didn't use any one of those yet. And I think it's very good basic actually to do a talk because I was very unopinionated about the libraries. So I'm sorry, I have no idea.
Sure.
That's actually a quite an interesting point, actually, because we do similar things in Rebel Labs. Actually, a lot of the time we look at things from a very neutral background, which makes us quite strong in terms of how we can compare things. But yeah, I'm just checking RC, and I don't think we have any other questions. There's a lot of talk in here still about modules. So I don't think we have any other questions.
Henrik wants to say.
Yes.
Go for it, Henrik.
So my question is about error handling or exception handling.
Yes.
Does most of the libraries provide exception handling when doing like asynchronous stuff? Because
yeah, I think, for example, the reactive libraries usually do, like we've seen with RxJava. It has some special error handling code where you could say on error, do something else, or we can also delay the errors until the end of the stream and also get errors back at the end of the stream. But I think it's a very interesting topic, and I think a lot of libraries are not really sure if they should do the exception handling themselves, or they still should leave it to the user.
Yeah, because you had this example, I don't know, it was the second library or so.
Yeah, with Jewel, with the unchecked.
With
right?
this unchecked exception,
Yes.
right? And I asked myself, So if you have a parallel stream and you do it like this,
yes,
what will happen?
so you have a runtime exception then, right?
Yeah, in any thread, and you
Yes,
don't
yes.
get it, but you have a for each at the end. So what will happen in that case, for example?
I think it will throw the exception when it's, yes,
some kind of,
for some of the values which
Yeah.
which are not okay, and then we'll stop doing the system out println at that location, for example. Yes. So it's really kind of a problem,
Yeah.
right? You're just saying, okay, I don't want to have a checked exceptions, but you're very unsure about the error handling them. Yeah, that's right.
So we have one question in IRC, and that is from Stephen. And Stephen says, do you believe that you could stop using lambdas now that you have them? And I guess the question is similar to if now you have this experience with lambdas, would you, and if Java didn't have it anymore, would you leave Java for a Groovy or dare I say a Scala?
I don't know. I never used any of the other languages, so I really like the lambdas, and I didn't mean to criticize the Java team in any way. So I think we had some very nice additions to the languages already. And I think it's very, very good good way to only be very conservative in adding new API. I mean, we already see it with optional, for example. They want to deprecate the get method. So this was already like kind of a mistake. And if you just add new API and people start using it, and then you want to deprecate it again. So it's better to start with a small set and then, like I said, analyze the libraries, what people are doing on GitHub, for example, do some static analysis, and then they find out which methods could be really useful and maybe add them to the API again. So no, I definitely don't want to go back to the time where we have to write some anonymous inner classes to actually have the same functionality. It's so nice to read.
Oh yeah, for sure. Okay, so let me just check if Daniel is going to be joining us.